So we want to do yet one more example of a linear homogeneous recurrence relation with a repeated root. So I'm already telling you up front there's a repeated root to the characteristic equation. So let's get started with this guy. Hopefully I wrote it down correctly. Let's see, characteristic equation is the first step you're trying to solve. All right, so degree 3, right? Recurrence relation has degree 3 from n to n minus 3. That's the end. Space of 3. Now, characteristic equation will have degree 3, so we're going to make r cubed equals minus 5r minus 7. No, minus 5r squared. Come on now. Minus 7r minus 3. Add 5r squared to both sides. Add 7r to both sides. Add 3 to both sides. You get r cubed plus 5r squared plus 7r plus 3. And on the right-hand side, 0. And factoring this is not your easiest thing in the world. How would you try factoring, you maybe wonder? There's no nice, like, some cubes, really, because 3 is not a perfect cube. So what you could do, you could use, look for possible rational roots. Possible rational roots. And you could see if maybe there's a root you can figure out. So the p's are going to be the divisors of 3. Plus or minus 1, plus or minus 3. There aren't very many, right? And the q's are going to be the divisors of the coefficient of the largest term, the r cubed term. So the coefficient is 1, so the divisors are plus or minus 1. So your p over q's are going to just be plus or minus 1 divided by plus or minus 1, plus or minus 1, plus or minus 3 divided by plus or minus 1, plus or minus 3. But basically you have 4 possible rational roots to consider. You could try plugging in 1, -1, 3, -3, and trying those out. Let's see. Let's try. I actually already know what's going to work here. Let's try r equals 3. I've already tested this. If I plug a 3 in, by making a template, so what I'm going to do, I'm going to plug a 3 in here, place of r. No, -3, my bad. Try -3. -3. Yeah, 3 wouldn't work. Everything's positive, it's going to get really big. All right, so here you're going to have what? -27. 9 times 5 is going to be 45. -21 plus 3. So the first 2 is going to give you 18, right? And the second 2 is going to give you minus 18. It's going to zero out. Aha, we found a root. -3 is a root. So that means r equals -3 is a root. You could say it's a root of the equation or of the polynomial. So that's going to mean r plus 3 is a factor of the dude. What was the polynomial here? Where's the polynomial? Scroll. R cubed plus 5r squared plus 7r plus 3. R cubed plus 5r squared plus 7r plus 3. That polynomial. So what we're going to do is long division. Long division, we're going to take r cubed plus 5r squared plus 7r plus 3, and we're going to, that's called our dividend, and we're going to divide the divisor r plus 3 into that, and we're going to get a quotient up top. Let's see. So first of all, we have to ask the important question here. What times r is going to give us r cubed? Well, r squared. So I'm going to write an r squared above the square column. So r squared times r is going to be r cubed. I'm going to take r squared times plus 3. Just going to give me plus 3r squared. Okay, now I'm going to subtract. A little yellow subtraction sign here. So r cubed minus r cubed is 0. 5r squared minus 3r squared is going to be 2r squared. I'm going to bring down my blue, positive 7r. I'm going to ask the all-important question, what times r is going to give me that 2r squared? Well, positive 2r, right? So I'm going to write positive 2r in the r column up top. So positive 2r times that r is going to be 2r squared. And positive 2r times that positive 3 is going to give me positive 6r. And we're going to subtract. I'm going to use green this time to subtract. I'm going to do what? 2r squared minus 2r squared is 0. 7r minus 6r is going to be 1r. So we're going to have 1r plus 3. Then we're going to ask the all-important question. Okay, what can we multiply this r by here in the divisor to get the 1r? Well, positive 1, right? We're going to take positive 1. Positive 1 times this r is going to be 1r. And then that positive 1 up top times that positive 3, and the divisor is going to be positive 3, and look at that. We can subtract these guys. Purple sort of color, violet color, whatever. Subtract those guys, and you get a remainder of 0. So when you get a remainder of 0, that means it factors out nice. So, back to factoring. What we had earlier, the polynomial, is going to factor into r plus 3 times r squared plus 2r plus 1. So this is the quotient and the divisor. So r plus 3 was the divisor. R squared plus 2r plus 1 is the quotient. That's going to be equal to 0. That was all scratch work. All right, now we got what? R plus 3. And then we can factor r squared plus 2r plus 1. This is going to be a quadratic. That factors nicely. So we're going to have what? R here and r here. Multiplying to get r squared. We've got to find two numbers that multiply to give positive 1 and add to give positive 2. We do what? Plus 1 and plus 1. Right? Plus 1 and plus 1. Multiply to give 1. Plus 1 and plus 1. Add to give 2. So what do I got? I got r plus 3 multiplied by r plus 1 quantity squared equals 0. So you're going to get two roots, negative 3 for the factor r plus 3 and negative 1 for the factor r plus 1. So it turns out that r equals negative 3 has multiplicity 1, and r equals negative 1 has multiplicity 2. Why multiplicity 2? Well, look at the power there, right? The power there. The power over r plus 1 there. It's 2. All right, so let's write down the form of our solution. The form of the solution is going to be a sequence, a sub n equals. So for our first root, negative 3, we're just going to have alpha 1, 0, and we're just going to stop there. Since it's multiplicity 1, we're just going to stop there, and then we're going to put negative 3 to the n power. You just have a single coefficient there. Now, for our second root, which is negative 1, we have multiplicity 2, so we have to write in parentheses alpha, so 2, for this is the second root, alpha 2 is 0, plus alpha 2 comma 1, n to the 1 power, and we're going to stop there at the 1th power, and that's because the 1th power is 1 less than the multiplicity, which is 2. And then on the end, after we close the parentheses, we're going to put negative 1, our root, to the nth power. So that's the form of our solution. All we have to do now is find the coefficients, right? Come on now, the alphas. Shall we find the alphas? Alpha 1, 0, alpha 2, 0, alpha 2, 1. We're going to get those from the initial conditions. Initial conditions were what? 1, 3, and 5. So 1, 3, and 5. I can remember that because those are easy to remember, 1, 3, and 5. So I guess I'm going to do it down below because I don't have a ton of room on this iPad thing. So we're going to find alpha 1, 0, alpha 2, 0, and alpha 2, 1. I'm going to set up some equations. A0 1, A1, 3, A2, 5. So basically what we're doing, in place of these n's here, we're going to first start for A0, we're going to replace with the 0, right? So when you replace with the 0, those n's, you should get, what should you get? Well, negative 3 to 0 is going to be 1, so you're going to have alpha 1, 0, plus, let's see, parentheses, alpha 2, 0. When I plug in n, and that after the alpha 2, 1, that's just going to 0 out. So I just have alpha 2, 0 times negative 1 to the, oh yeah, you got to plug it in here as the exponent as well, above the negative 1, be times negative 1. All right, so that's the first equation. We'll worry about simplifying that later. Second equation, a sub 1. A sub 1, let's see, I'm going to plug in a violet 1 in place of the n's. What do I get? I'll get a negative 3 to the 1 power, give me a negative 3, so I'm going to have negative 3, alpha 1, 0, plus parentheses, alpha 2, comma 0. Now I'm going to plug in a 1 into that n after the alpha 2, 1. It's just going to give me 1 times alpha 2, 1. In other words, alpha 2, 1. And I plug in 1 into the power above the negative 1. I'm going to get a negative 1. Oh, wait a second. I have something here I don't need, right? I don't need that. Right? Negative 1 to the 0 power earlier is just going to be 1. So I don't need that. It's just going to be alpha 2, 0. Okay, messed up. Yep. And when we plugged in 0 earlier for a sub 0, when we plugged in 0 earlier, negative 1 to the 0 is just 1. All right, now on to the last equation. So I'm plugging in 2 for n in the form. When I do that, I'm going to plug in negative 3 squared. I'm going to give a 9, right? 9. So we're going to have 9, alpha 1, 0, plus parentheses. I'm going to have alpha 2, 0. And then I plug in a 2 for n after the alpha 2 one. I'm just going to give me 2, alpha 2, 1. And then I plug in a 2 for n above the negative 1. That's just going to be negative 1 squared is going to be 1. So I don't need to write anything. All right, let's clean this up. Can we clean it up? Hopefully. I have alpha 1, 0. Come on, man. Plus, what else? Alpha 2, 0. All that's equal to 1. That's the first equation. Second equation is going to be minus 3, alpha 1, 0. And when you multiply here by this negative 1, where's that negative 1? This yellow negative 1 right here, that's going to flip the signs. We're going to have what? Minus alpha 2, 0, minus alpha 2, 1. So I just distributed negative 1 through those two terms here in the yellow parentheses. And on the right-hand side, let's see, of the equation, we got, what, 3. And the last dude, we got, what, 9, alpha 1, 0, and nothing happens on those. We just write alpha 2, 0, plus 2, alpha 2, 1, and that's equal to 5. So you can solve those by hand if you're really ambitious, or just enjoy solving them by hand, but I'm going to use an augmented matrix, or reduce it with my calculator. So I'm setting up a matrix with coefficients 1, negative 3, 9 in the first column. In the second column, I'm going to have coefficients 1, negative 1, positive 1. In the third column, I'm going to have 0, negative 1, positive 2. I'm going to put a bar represents the equal sign, and then on the right hand side 1, 3, and 5. I'm going to reproduce this through RREF in the calculator. I've already done this from the calculator. Thank you, calculator. Reduce row echelon form. 1, 0, 0, 0, 1, 0, 0, 0, 1. And on the right hand side, they got 3, negative 2, 10. 3, negative 2, negative 10. Sorry, negative 10. I said it wrong. So I'm going to get 3, negative 2, 10 are going to be my alpha 1, 0. It's going to be 3, alpha 1. I'm sorry, 2, 0. Alpha 2, 0 is negative 2. Alpha 2, 1 is going to be negative 10. All right, now I'm going to plug these back into my, so 3, negative 2, negative 10. Plug these back into my form to get my exact solution here. So a sub n equals alpha 1, 0 was 3, so it's going to be 3 times negative 3 to the nth power plus parentheses alpha 2, 0, remember, was negative 2, so negative 2. Alpha 2, 1 was, what was alpha 2, 1? Minus 10, yeah, minus 10. It's multiplied by n, and then that's multiplied by negative 1 to the nth power. Okay, there it is. There's your final solution. Sorry we had to do scratch. That's not scratch work below, but sorry we had to do the work below. Normally when you have your paper, you organize a little better than this. I just don't have a lot of room to write, so yeah. So there's your solution. Yeah, this is pretty much the end of repeated roots. I won't do any more examples of repeated roots. It's kind of tedious, right? Yeah.